Hello, in this tutorial we're going to visualize physiologic ECG interpretation or the normal standard step-by-step ECG interpretation methods. So as first point, you start off with the rhythm. So for the rhythm, we need to know that you can have a sinus rhythm, you can have the next rhythm that you can have a nodal rhythm. The next rhythm that you can have a junctional rhythm, you can have ventricular rhythm. So those are different rhythms that you can have on ECG. Now, let's start with the first element, which is the sinus rhythm. So for the sinus rhythm, we need to point out the fact that every time that you have a sinus rhythm is when a P waves directly comes before a QRS complex. Is it clear? If a P wave come on the QRS complex, particularly on limb lead 2, so the limb lead 2 is a major part or the rhythm strip. Generally, for you to visualize a rhythm, you have to go on the rhythm strip. And I've said before that on your ECG paper, let's say that is your ECG paper. This is the lead 1, this is lead 2, this is lead 3, and down the last portion of the ECG paper is going to correspond to the rhythm strip. That rhythm strip is actually helpful in order for you to visualize the rhythm and the regularity and the rate. Is it clear? The rhythm strip is the best lead, the best part of the ECG that you can visualize the rhythm, the regularity, and the rate. Are you understanding? And this rhythm strip can either be limb lead 2 or limb lead V1. So if you have an ECG paper that does not have a rhythm strip, you can go, in order for you to visualize the rhythm, the regularity, and the rate, go on limb lead 2 or you go on limb lead V1. Are you understanding? To visualize the rhythm, the regularity, and the rate. So for the rhythm, go on the limb lead 2. If you have a P wave that comes directly before a QRS complex, that is a sinus rhythm. Is it clear? Now, the next one is a nodal rhythm. So for a nodal rhythm, you are going to have on the limb lead 2, you are going to have an inverted P wave and you have a QRS complex. If you have an inverted P1 limb lead 2 and a QRS complex, that is a nodal rhythm. And I've forgotten to tell you, on V1, normally what you're going to see is that on V1, the P wave corresponds to two parts. You have a positive aspect of the P wave and a negative aspect of the P wave. Then you have a predominant S wave in the QRS complex, and then you have the T wave. Is it clear? That is like that. So those are the different aspects on this. So if you visualize now an inversion of this P wave, it is still a nodal rhythm at the level of the V1 fibers. So those are the different aspects that you have to understand. So the next rhythm that you have is the junctional rhythm and the ventricular rhythm, which is out of the scope of our tutorial. Now the next thing is regularity. Now for the regularity, you have to see if it is regular or if it is irregular. Now, if it is irregular, you can also add up the fact that it can be regularly irregular if it has a particular pattern of an irregularity, and it can be an irregularly irregular if it has no pattern of the irregularity. Is it clear? Now, for you to visualize if an ECG is regular, what you just need to do is that, let's say that this is our ECG paper, like this. Let me just draw a small ECG paper like this. I draw a small ECG paper like this. Okay, so for you to know the regularity, what you just do is that you take the edge of a paper. When you take the edge of paper, go at the level of the rhythm strip. Is it clear? Or if you don't have a rhythm strip, go on the limb lead 2 or limb lead V1, because they are the best to visualize the regularity, the rhythm, and the rate. So you take the edge of the paper, you now draw, you have a point from the R wave. Let's say that I visualize the R wave, I put it here, and now I visualize another R wave, I put it where. Now I compare with the next RR complex. You see that it is the same. I compare with the next RR complex. You see that it is the same. So it is regular. Is it clear? So you put it here, you compare, you see that it is similar. You see, so this distance and this distance are similar. You come here, compare this distance and this distance is similar. You come here, compare, so it means that it is regular. Now, if it is irregular, let's say that you have instead another ECG as such. So P wave, the QRS complex, then you have the P wave, the QRS complex, then you have the P wave, then QRS complex, then you have the P wave, the QRS complex. So in this case, you first have to identify with the age. So from this one to this one is 1 hour interval. And how come I do here? You see that there is difference in this hour interval. I come here, I do here, there is a difference in hour interval. It means that it is irregular. And now if it follows a particular pattern, you see that it is regularly irregular or irregularly irregular. If it follows a particular pattern, it is regularly irregular. So those are the different elements that you have to visualize on the ECG. Now, for the after the regularity, the third element that you have to visualize is the rate. Now, to calculate the rate on the ECG, you have to know that you calculate the rate based on the regularity. Now, if it is regular, we use the rule of 1500 or the rule of 300. Now, if it is irregular, we use another rule, which is the rule of the 6 and the rule of 10. Which when it is irregular. So when it is regular, you use the rule of 300 first. So in the rule of 300, what you have to do is that, let's say that is a QRS complex, this is a P wave, this is a QRS complex, then the T wave, then we have another P wave, then you have the QRS complex, then you have a T wave. So let's say that these are the number of big squares. So let's say this is big square, 1 big square, this is 2 big square, and this is 3 big square. And inside that big square, you have small squares as such. Small square as such. Small square as such. 1, 2, 3, 4, 5. So let's say that this is an ECG slip. Is it clear? So in this ECG slip, what you understand is that in order for you to calculate for the rule of 300, is it clear? For the rule of 300, what you have to do is that you just do 300 divided by the number of big squares. Is it clear? So 300 divided by the number of big squares. So in this case, the number of big squares between 2 hour intervals. Is it clear? That is the rule of 300. It's 300 divided by the number of big square between 2 hour interval. So what do I mean by that? So for this ECG, what you have to do is that you calculate, this is 1 hour interval. This is another big square. Let's say this is the ECG. Here's your P wave. Here's your QRS complex. There's another, this is a T wave. Then you have another one. Here's the P wave. Here's the QRS complex. There's a T wave. Are you understanding? So let's see that this is your ECG slip. Are you understanding? So now what you have to understand is that you have to calculate, this is the R wave here, this is another R wave on the limb lead 2. You calculate the number of big squares in between these two R waves. So there is one big square in these two, in between this R wave. There's another big square and there's another big square. There are 3 big squares. Are you understanding? So you just do the rule of 300, say that you do 300 divided by 3 is equal, it gives you 100 beats per minute. Are you understanding? So that is the rule of 300. So for the rule of 300, you just calculate, it gives you 100 beats per minute. Are you understanding? Now the next thing is the rule of 1500. Now for the rule of 1500, it is much more precise, provided that you don't have exactly 3 big squares, but you can have 3.5, you can have 3 1/4 big square and all that. You now use the rule of 1500. So the rule of 1500 is 1500 divided by the number of small squares. Is it clear? Divided by the number of small squares between two RR intervals. So what do you do by that? You calculate, this is 1, so you need to calculate this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in all, you're going to have 15 small squares in between two RR intervals. So what you do is that you do 1,500 divided by 15. So you cancel and cancel, it still gives you 100 beats per minute. So provided that you don't have exactly 1 big square, if you don't have exactly the whole number of big squares in between two RR intervals, what you have to do is that you calculate the number of small squares and then you do 1,500 divided by that number of small squares, because it helps you to be precise. Now, after that, after the identification of the rate, we now move to the fourth element, which is the P wave. So when identifying the P wave, the first thing that you identify is the morphology of the P wave. Is it clear? In the morphology of the P wave, you have to know that the P wave is